Alright, in this lecture we are going to discuss about the gate level modeling for the half adder, continuing our series for the lecture 4. I guess 1 2 3 lecture 4. So in this lecture we are going to discuss the gate level modeling, and we were discussing the half adder. So we will discuss in the context of the half adder that how we do gate level modeling. So for the gate level modeling you need to be uh, you need to be informed about the combinational logic and the essential building block and the gate level implementation. So let me tell you one thing, that how half adder is designed. A half adder consists of a input A and an input B. Then there is one sum and there is one carry. Or in case of full adder, there is one count in also, C in also. So that will give us the full adder count. But right now we are discussing only for the half adder case. So we give two inputs A and B, and we receive a sum and the carry out. Okay, so this is a gate level implementation of our half adder. uh, Let us see here. Firstly, you need to be aware about the combinational logic applied here, the essential building blocks, and the gate level implementation, that how we are going to implement using the simple gates. Because in the gate level modeling we are not going to do a lot of programming. We are going to use the basic gate implementations only. From basic gate implementation, firstly we need to know about how half adder works. So there is a truth table, A, B, sum and carry. The implementations is for the sum. If we solve this using K-map or the simple min terms, you will get the A sum as A XOR B and the carry as A and B using the simple table. So we are now known about the gate level implementation, that using how we are going to assign sum in terms of A and B, and how we are going to assign carry in terms of A and B. Okay, so this is how we assign. The sum is just XOR of A and B, and carry is just AND of A and B. Okay, so gate level modeling. So simple syntax, we just write the name of the gate, and if we want to instantiate our gate with some name, we will give it some name. Then we will choose the output, that is, some say we have output S and we have input 1, input 2. Depending on the kind of gate you have, number of inputs you are selecting, here will be output, then there will be a series of input, that doesn't matter. Okay, so we are going to use here primitive gates like AND or XOR not. There are some other gates also. I have written the name here. AND gate, we have OR gate, NOT gate, NAND gate, NOT gate. For the NOT gate there is one single input only. NAND gate, this NOR gate, XOR gate, XNOR gate, there is buffer and not inverter. So this is how we write program. If we want to write AND, then we will write AND gate. We have to assign them as a wire, because they are right now working as a wire. We can assign them as a reg type, but we need to assign them as a wire because they are now getting connected. Inputs, if we are taking, they will assign them as a reg type, but if there is some other connection in between, we will see for the full adder case that if there is some intermediate connection, we need to assign them as a wire in case of gate level modeling. So if we wish to give it name, we will give A1 and YA, and NAND we will just, and OR this is case, NOR this case, XOR this case, XNOR this case. NOT, we will just take output and one single input that we wish to invert. So these are, you can take screenshot or whatever. I will share the PDF if you want, comment. So this is a full adder gate implementation, and there is a half adder gate implementation using data flow, and there is a gate level modeling. Like I told, there will be some intermediate wiring involved, like there is this wire involved. We are known about these wires, these two end wires, but there will be these intermediate wires which we need to name also. So right now here it is not given, we will discuss in later class. Let's say here we have given input, output, sum out, and wire cout bar. We could have given it a wire also. We will see now. This is the basic syntax. Right now you do need to focus. We discussed this kind. This is known as data flow modeling. We discussed in the previous videos. This is how we write. This is our program module half adder. We will instantiate our ports here. naming the ports, and we will write XOR the name of the gate sum A and B, and the name of the gate we will wish to assign carry A comma B, and then we will do end module. Okay, we will see the test benches. Okay, now let's proceed towards our program. So we want to create this, so let us module half adder. Let us give our ports A B sum comma carry. What happened, why this is something new? So now we will give the inputs A comma B, and there is why this is, just a second, let me refresh it. I guess it is fine. Module half adder A comma B comma sum comma carry. I don't know why it is going inside. Let me see if this is because of the font size. Okay. Oh. Now we will give the types of the our ports input A comma B and output sum comma carry. Now we will just use the basic gate level implementation we are discussing here. Gate level modeling for half adder. Okay, so let us write for the gate. Firstly, we seen how we design our uh, half adder. For the half adder, there is one XOR for sum and there is AND for carry. So let us do that. XOR, let us write it as XOR x1. We will give the sum and the sorry, we will not, it is S, and there is A comma B as input. S is output and A B is input, and there is one AND x2, and inside this we will give carry A comma B and of A comma B. So that's it. We will now do end module. So we created our basic program, that how to create a program using gate level modeling. Now we need to create a test bench. So in the same window I will create a test bench. You can create in other file also in case of Xilinx Vivado or other file. So ID, so we will write half adder underscore tb. I will declare them as a reg type. For A comma B, I will declare wire to S comma C. Then I will instantiate, connect this module half adder. I will call this adder inside this block half adder dut design under test dot A to A. We are connecting dot A to A, dot B to B, dot B of this program to dot B of this, and dot S to S, comma dot C to C. That's it. Now the only thing remain is initial. Begin. We need to create a block where we will assign the input values. So this is a half part. This is a half part, another part. So initial begin part, we will just let's display our values. We are going with A, B, then there is sum carry. Now let's monitor them. So let's monitor first time, percentage T, percentage B, percentage B, percentage B, percentage B, percentage B. Now let's take time here. Time, comma A, comma B, comma S, comma C. Now let's give some values to them. A equal to 0, b equal to 0. Let me copy them and paste. Control C, Control V, Control V, Control V. 0 0 0 1 1 0 1 and 1. That's it. Now we just do end. One second, we need to finish it. So FINISH, then we do end, then we do end module. That's it. So we created our programming file. So inside this is the main file that will execute. Here is the test bench, which we are using to display the outputs corresponding to this program that we implemented. Let us execute this program and see how it is working. So we are displaying the A, B, sum and carry. So at 0 0 0 there is nothing as value assigned. We did not assign any values to it. So at 10 we have given 0 0, at 20 we have 0 1, so the sum is 1 and the carry is 0. At 30 second the A is 1 and B is 0, so sum is 1. At 40 second 1 1. Achha. At 40th second this is A is 1, B is 1, so sum is 0 and carry is 1. So that is how we implement any program using gate level modeling. So right now we discussed three types of modeling: gate level modeling, data flow and behavioral modeling. So next part we will discuss the case for half adder. So this will be your job to try to create a full adder using this gate level modeling. Just remember how the gates are connected. Try to implement this. We need these extra also. Let us see which extra. We need this one extra also, the end of this. So we will and you use this one also. We will need to use this one also. We can see this one also, that this one is a half adder, this one is also a half adder. So we can say that a full adder is a combination of two half adders. Okay, so uh, we will see in the further lectures that how we can call uh, different modules and use different modules in different file. We need for that we will need to use Xilinx Vivado. So from the next lectures, if I will try to use Xilinx. So this lecture we discuss gate level modeling. I hope you understand. If you found any confusion, if you were unable to understand this, you can comment. And regarding the PPT for the lecture, you can comment if you want. I will upload it. Thank you.